Our next speaker is Jennifer
Archambault, yes.
And she'll be talking about the question of whether contaminant removal by native mussels in the Mississippi River is an ecosystem service.
Thank you, Sabina, for that introduction. Good morning, everybody. I'm going to be talking to you about the first phase of my dissertation research involving native freshwater mussels and pollutant ecosystem services. I'd like to begin by acknowledging the National Fish and Wildlife Foundation for supporting my research, the Carolinas Regional Chapter of CTAC for helping provide travel funding for my trip here today, and the North Carolina Foundation for Agrimedicine and Toxicology for providing a scholarship that helped some of my summer research. Of course, I received support for laboratory analytics, field assistance, and administrative support. And I would also like to acknowledge the Chippewa Nation, who are indigenous to the land we're on today. So I'll just begin by indoctrinating you all into the world of our native freshwater mussel fauna, if you're not familiar. These mussels are in the family Unionidae. They are spread worldwide, and there are nearly 700 species. And as of the most recent taxonomic revision published last month in Freshwater Mollusk Biology and Conservation, we recognize 298 species in North America. These mussels are found in our rivers, streams, lakes, and ponds, and they are unique among all other bivalves in that they are an obligate fish parasite. So I've shown the life cycle here on a graph, and you can see that the larvae require to parasitize a fish host in order to fully metamorphose into a juvenile before dropping off and becoming a benthic-dwelling adult. So this is an interesting way and a pretty precarious way to reproduce. But you can see by this GIF here that mussel moms have some clever evolutionary adaptations for getting those larvae on a fish. And so she's got something that looks like a prey meal, and her marsupium is sticking up there. Uh-oh, I hit the wrong button. There we go. Okay, just to be clear, these are not zebra or quagga mussels. So those are in a completely different order, and those are the invasive species. Just a word on the conservation status of our native mussel fauna. Bleak comes to mind. More than 71% of our species are considered imperiled. That's either federally or state listed or otherwise of special concern. This is an outdated number from 1993. We've been anxiously awaiting an update, but hopefully it doesn't change for the worse. There are many reasons for their decline, but you can see on this graph that habitat alteration and destruction has been most frequently cited in the literature, and that includes both physical habitat changes like damming and pollutants such as point source and runoff. So just to touch a bit on the history and importance of native mussels to humans, they are of historic importance. Native Americans used them for tool implements, jewelry, and other things. And about in the 1870s, I believe, the first freshwater pearl was found in our native mussels. Now, most mussels don't produce a pearl, and most of them that do don't produce one that's marketable. So a pile of pearls like this represents an enormous amount of mortality. And you can see in this picture here, these are piles of shells that have been harvested from the Mississippi River. And for reference, these are boats and a person. And then somebody made a German immigrant by the name of Boppel, created a Boppel button lathe where they could use the thick-shelled species to create hole punches for buttons. So if you have a vintage shirt, or maybe your parents or grandparents have a shirt that has buttons that are actually made of freshwater mussel shells. So these critters were largely over-harvested in the late 1800s and early 1900s. A bit on the history of the pollution in the upper Mississippi River, and let me orient you to what the upper Mississippi River is if you're not familiar with this drainage. It goes from the headwaters upstream of St. Anthony Falls here in Minneapolis all the way down to the confluence with the Missouri River, where it becomes a much larger and deeper river and was historically much more navigable before we altered the upper river. The early polluters in this area were the sawmills and the meat packers. I don't know why there's a line there. That was not there before. But the sawmills were largely cutting down the white pine forests that used to be here and in upper Wisconsin and upper Michigan. And so a lot of their waste went into the river, as did meat packers that were prominent in the region. So the upper Miss was free flowing through the 1900s, and the first dam was built in 1907. And then since then, there are now 29 locks and dams, the system on the upper Miss that makes it largely navigable. Sewer technology was needed when these, I'm sorry, I got distracted by the issues on my slides. Sewer technology was needed for these growing cities, and that basically meant taking the sewage that was in the streets and piping it to the river. But as you can imagine, dams and pollution created unanticipated consequences, such as human disease outbreaks, and contributed to the mussel fishery collapse. We certainly have been cleaning up our water since the Clean Water Act, but today, of course, we need to concern ourselves with emerging contaminants and contaminant mixtures. So we're in an ecosystem services session, so how does that relate to contaminants and native mussels? Mussels provide many ecosystem services in all the four major categories that we recognize: regulating services, supporting services, and provisional and cultural services. I touched on some of those. For regulating services, they're water purification. They've been deemed the livers of the rivers, so they filter out bacteria, E. coli, algae, other particles. They also participate in supporting services by cycling nitrogen and storing carbon in their shells and things like that, as well as bioturbation, such as oxygenating the sediments for the food base for things that humans do care about, like fishing. Pollutants, though, have largely been studied from a toxicity perspective, so the concentration which would cause a deleterious effect to the animal, but we really know little about pollutant removal from the ecosystem service perspective. So that leads into the objectives of my dissertation. I wanted to quantify the contaminants of in native mussel populations, so scale it up to the population level. And there are several other objectives to my dissertation work, but I'm going to be focusing on this one today, and I'll circle back to these other ones to let you know where I'm going after this. So our study area were two pools in the upper Mississippi River, Pool 5 and 18. Pool 5 is located not quite halfway between here and La Crosse, Wisconsin, and Pool 18 is further down between Iowa and Illinois. So we did systematic population surveys. Everywhere there's a dot, there was a survey to determine the dominant species and estimate populations. From there, we selected the dominant species for collection, and we collected from the upper, middle, and lower reaches because these have different habitat qualities. So the upper river tends to be more run-of-river habitat, the middle of the pool tends to be more slack water conditions, and the lower parts of the pools tend to be more impounded conditions. After collection, we dissected the soft tissues, homogenized, freeze-dried, and stored them at -80°C until we sent them to laboratories for analysis. We analyzed for 22 metals and many organic compounds, but stay tuned for the organics. We've just recently received those data back. And of course, these laboratories use standardized EPA methods. So on to some results. In Pool 5, we found 16 species and estimated the whole population to be about 190 million mussels. And this graph kind of just shows density differences. So the tiniest dots are less than 1 mussel per square meter, whereas the largest dots are greater than 30 mussels per square meter. And the dominant species here were the three-ridge mussel, up top, the Wabash pigtoe, and the plain pocketbook. And you can see that even though people don't get to see them a lot, they are rather charismatic in their names and their shell shapes and forms. In Pool 18, we had 23 species with about 212 million mussels for the total population. Again, the three-ridge was among the dominant species, and then we had the three-horn wartyback and the maple leaf mussel. So what about the metals? I'm going to report on the total metals today. So I've got our 3 species that were collected and showing you the total metals, so the sum of 22 metals, the average from each of these species, ranging from about 9,600 parts per million in the three-ridge to over 12,000 parts per million in the plain pocketbook. So how much is in the population? That's kind of a difficult thing to answer, and that's probably why nobody has looked at it from this perspective before. But what we did was kind of do a general calculation of the average concentration in our dominant species with the average mass of these species and scale that up to the population of 190 million mussels and come up with about 11.3 tons of metals are stored in the soft tissues in the mussels in just pool 5. So in pool 18, I have them again shown from least to most, total metals from about 6,800 to just over 10,000 parts per million in these species, and we did that same general calculation to determine about 6.8 tons of metals in the tissues of our native mussels in pool 18. So these findings suggest that they do provide an additional ecosystem service of pollutant sequestration, but we do want to compare the tissue numbers with those in water and sediment, which we have collected and are on our way to analyzing, to understand the magnitude of this effect. So is it a drop in the bucket compared to what's environmentally available, or is it a substantial service? Of course, this is a detriment to mussel health, whereas cycling nutrients is beneficial for the mussels. And I mentioned that these are already a highly imperiled group. So it goes without saying, but I'll say it anyway, that conservation and pollution reduction are imperative because large healthy populations are going to equate to better water quality, and declining service will mean the loss of those other ecosystem service benefits that result in things that people care about, like water clarity and color. So in summary, what did I just tell you? Mussels and people and their relationships have been central to the upper Mississippi River's environmental history. Freshwater mussels were exclusively once valued as an exploitable commodity, but healthy populations do provide enormous ecosystem service benefits. Those are not readily visible to the beneficiaries, though, and that's something that we want to work on. Between the two pools, mussels had about 18 tons of metals stored in their soft tissues. I haven't talked about organics yet, so you can imagine that that's going to, the reservoir of contaminants is much higher once I will consider that. And this number likely does flux, but there is a long-term storage in a healthy standing population. And also metals that have the same charge as calcium would be able to be stored in the shell material, and that's something else we're interested in looking at. So next, I'd like to investigate the toxicokinetics of some of those metals to understand more about that flux. And then finally, we will be doing a social science piece where I will conduct focus groups to understand people's perceptions of what they think affects water quality. So we can connect how they judge water quality with the things that actually affect it, such as these invisible critters. Thank you.
We have time for a couple questions. Go ahead.
Yeah, maybe I didn't catch this, but what is the concentration of the metals in the sediments itself?
You didn't miss it. That's something that we have just collected this summer. So I have sediment samples, and I have passive sampling devices for the water. And so that's something that we'll be analyzing so that we will be able to understand what the magnitude is compared to the mussel tissues. So stay tuned. Yes?
Yeah, how important for these mussels is the production of pseudospecies as a mechanism for stripping metals from the water column?
I'm not sure how much of the metals end up in the pseudofeces. There is a little bit on the toxicokinetics of metals in mussels, but only some of that data is based on our native mussels. Others of it is based on toxicokinetics from Mytilus, the marine mussels, and from the Dreissenids, those invasive mussels. So I think they may be depositing some in the pseudofeces, which then ends up in the sediment. But that's what I hope that some of our toxicokinetic studies can answer those questions a little bit better. Mm-hmm. Yes, sir.
Yeah, so according to the metals that you analyzed for the samples, are you going to discriminate between those that are essential and those that are non-essential?
Sure, yes, and I've looked at that data a little bit, but it needs rigorous statistical analysis. So far, I can tell you that there are some that are of concern that were fairly low concentration, such as cadmium, which is fairly toxic to mussels, lead, those are pretty low concentration. Manganese seemed pretty through the roof, like over 4,000 parts per million was about the average, just when I was looking at the data in general. So we'll be taking a look at that and trying to understand too those essential versus non-essential and those that are more and less toxic.
Any other?
Compare your metal content in mussels to the other viable, such as clam or oyster.
So the question was, have we compared our...
In the clam and oyster compared to what you measured from the mussel.
Right, so I haven't really done comparisons with these particular data yet on that. But we do have some historic data on zebra mussels in the upper Miss that I'll be able to compare that to. I'm out of time, but thank you so much for your attention.